Thank you for the BlueHat committee for having us here. I see a lot of people are sleeping. So let's play a game, right? You guys are defenders. You've defended all your human identities. You've made sure all your human identities are secure. You've used MFA even for your guest users. Yet, a token which got leaked in 2020, I got access to it, and I'm able to log in. I'm active, and I have privileges. Who am I? And that's a question I think all of us as defenders end up having, irrespective of the tech stack we're in. Who has logged in? Specifically today, when we think of the cloud scenario. Because, trust me, attackers or hackers are not just hacking anymore. They're logging in, right? So this is usually a cat and mouse game. I consider it the infinite game when we think of game theory, right? It's a problem that will continue. But if we think about it further, and I am a millennial, I prefer when I think of games, I think of my gaming consoles, right? So let's take out your old 16-bit console where you have to blow the cartridges to play, and let's play a game quickly about what we're going to do to defend. I call this game the zombie apocalypse, right? And the vector I'm talking about was the non-human identity today that has increased in so much capacity, specifically because we have cloud involved in so many places, right? And this game, we're going to quickly play and try and understand how you as a defender can actually level the playing field. Like any good game, you need players. So I'm your player one. I'm a security researcher. My name is Joshua. I'm a researcher with Microsoft. I work to secure your cloud, your non-human identities, and sometimes I am busy also answering some of your questions as a customer. In most cases, if you don't see me with my head in the cloud, I'm on a motorcycle, or I'm DDoSing your feed with a lot of memes, earning me the name Advanced Persistent Memer. I'm joined by my co-researcher and player two.
I'm Shaleen Dev. I'm part of the same team at Microsoft. I'm a SaaS and NHI security enthusiast. While I'm not at work, I love to dance as well as to boxercise.
Boxercise, new terms. Much like, of course, with new technology coming in, like you, Shaleen, player two will come in when we need as we level up. So, like many things, we have a game, we have your players. Let's see the tools. And why NHI is important to monitor, right? And the non-human identity is nothing but your legacy machine identities which used to exist. But today we are in the cloud era, we're in the AI era, we're in the agentic era, right? And these numbers are growing. Today your NHIs are more important because they have sometimes more privileges than your users as well. Today, if you look at it, and this is based on statistics from 2023, a basic enterprise having cloud, usually the ratio between a user entity ID versus a non-human ID, the ratio is 1:17, and this number is growing with agents. So if this is a usual enterprise, what happens when we actually get breached? This is what we're going to try and make you understand as we play this game. But to play a game, it's also important to understand what are we playing, who are we playing against, and what are they using. So let me introduce you to our three main characters who will be involved in this little bit of a game, right? And who APTs kind of end up using. We have the compromised app. I call it the compromised ghosty. It's your legitimate application in Entra, right, which can be compromised because it's used legitimately, but someone's got malicious access to it. This is one NHI vector we're going to talk about, the OAuth application NHI. The vectors are large. So this is one. We have the malicious app, which is actually designed and planted by an adversary. You can call it the malicious ghosty. And of course, we have a third variant, which has recently come up quite a bit, the dormant ghosty, which is something that is quiet, inactive for a long time, but can be reactivated. And sometimes this can take both flavors. It can be a compromised application, which you've forgotten, or is actually a malicious one which was planted a long time back. But is that enough? If you think about when it comes to this, is a game enough without the playing field? So if you think of chess, we can't play chess without the board. If you think of football, we can't play football without the field. If you think of security, specifically defense, you can't play it without the MITRE matrix. I'm referring to the SaaS matrix from MITRE, can't take the entire thing here, because we're going to take a complete cloud scenario right now, right? So this is the matrix. If you see to my right, your left, we have our APT groups ready to come. And they want to go from right to left, to impact, to exfiltrate, to have persistence. And there you have your beautiful defenders, much like us, trying to defend and go from my left more to the right. And hence you have a playing field, right? So can we at least say it's game on, right? And a better way to understand this is actually seeing how they use this. So let's see how APTs end up using this vector quite a bit. Let's take the persona of APT-A. It'll use 2 of these applications I introduced to you, right? And let's see how they go through the kill chain. So this is an attack which happened against a product company. What happened is this company had some of its valid accounts, tokens available somewhere which were leaked due to another attack. These guys just logged in after a couple of years. So it just logged in with a valid and a compromised application. But then it also gained persistence, because what this adversary did is use this NHI to refresh its credentials, and hence it was in the cloud for them. What it did after that was it went into the entire credential access vector, right? Where it realized this, all clouds have vaults of some sort. Azure has the key vault. So, right, it went there and it realized, okay, we have keys, but do we have enough access? And it realized the same vault is shared by another dormant application which was there for testing, and it got access to that. And then it used that to actually start creating and stealing more tokens and actually gain privileges, because this particular application had privileges and no one knew about it. A dormant application coming to life. What happened then? It started doing alternative authentication. Your cloud, specifically when it comes to your OAuth applications in Azure, don't just talk to certain APIs, they talk to quite a lot of APIs. And they started doing alternative behaviors. They started going towards your infrastructure. And that's where they started doing account discovery, trying to understand what is in your cloud. And usually when it comes to product companies, nowadays they go after your repositories. Let's take another example, APTB. Right? APTB brings in another ghosty, the malicious ghosty, if you remember. What it does is, in this case, is we have to understand one thing. The previous case when I took, it was a single tenant in a cloud. With OAuth applications, the concept increases to multi-tenancy. It's somewhat like if you have an application on your phone, I have the same application on my phone. We have 2 instances of it. OAuth applications and Entra work in a similar fashion. This adversary knew this behavior very well, and it used it extensively. So, much like many companies, there was a test tenant which had an application, and they were able to get its keys, or sometimes they do password spray attacks. As I say, usually they log in. Because of the multi-tenancy nature, this application was able to jump into actually a production environment in the cloud using the same application, which actually compromised it. But was that enough, right? What it understood was it used this entire test tenant as a vehicle, like infrastructure we end up seeing, and it kind of reactivated some of the dormant applications as well. This application even created a user, which is somewhat unheard, right? Users create non-human identities. A non-human identity creating a user is completely new. It also did one thing different, and this is where the App-ocalypse bit comes in. In the test tenant, it registered not just 1, 2, but 20+ applications, which it then consented in to the production tenant using the same user. Now you can see the scale, right? Things are coming alive. You actually are seeing the scale. There's only one user involved, but we have 20+ applications in a varied segment of attack just through the skill chain. Now it has a lot of more way to spread, right? So what does it do usually? It uses these additional applications to do defense evasion, because usually when it comes to cloud, your models and whatever you're using for your defense, usually there is a threshold of behavior. But what if something is new? You don't have enough time to create a baseline. They were able to they added even more identities and made sure that they even stay under any radar when it comes to what they're doing. Defense evasion. What it further did was, using an application it found which was again dormant, and knowing that it had privileges, it started doing what anyone does, try to understand the infrastructure. It discovered it was adding certain applications to groups and removing them. This could be seen in seconds just to understand where can this particular user be added so that it has the correct privileges to do more damage. But it doesn't just end there. It then further wanted to understand where all are the credential passwords. And now credentials don't just matter just in your vaults or your systems. You have automation accounts which have tokens, you have keys, and anything can be used to do what we call lateral movement and collection. And it was using, if you see, the colors align with what each application or each ghosty is. It was using all of them in separate manner. But at the end of the day, its job was to make sure it had complete dominance of the cloud, even to the infrastructure layer, where it kind of got alternative authentication. But in all of this, this is all the moves that the adversary did. But there was one context that really drew up to us as NHI researchers. When we think of a human identity, when we think of dormancy, right, inactivity, we think of, hey, this person has not signed in, used the account for whatever time frame you consider. When it comes to NHI, or in my case, this one NHI I'm considering, the OAuth application in your Entra, we have to consider a lot of factors. We have to consider its API activities. We have to consider what token does it have. We have to consider what it has signed into, and we have to also consider who has signed into it and when. Because NHIs are very vital to your cloud systems, much like the service principal or your OAuth applications in Azure. And hence, this definition became a very vital factor when we were trying to baseline it, understand it, more importantly, just make sure that when this one application scales up, right? I'm not showing just one application. I'm saying your zombies applications come alive. You have an understanding that these are my zombie or dormant applications. With this context, the kill chain becomes a little easier from a defender point of view. If you remember, this is all that happened. But this is where we come in as defenders, right? We can now, based on these contexts, start writing detections, which actually can take back detection to as early into the kill chain as possible, specifically making sure that we're understanding the behavior of the NHI in context to the other, designing models that can catch anomalies, and more importantly, be able to take it as far back as to understand that this is completely anomalous when it happens for the first time. It applies to the same vector again. And this makes it more easier because now you understand, if you are using graphs today, right, that there is a common user here. And based on that context, your applications can easily map out. And you can go back further to even write detections as far back into the kill chain, making sure that we are not just there, but we are visible in all aspects of this kill chain, writing detections, creating visibility, and making you understand that NHIs are here and some of them are coming back to life. But I think the question comes here, right? Is detection enough? Are we truly then playing a game? Because it's unfair, right? If I can't play football and if I can't score a goal against you, that's not a fair game. So this is where detection is not just enough. This is where we need something a little more to level the playing field. Hence, I'm going to call in my player 2 to talk about the next bit of disruption.
Hey everyone, Shaleen here, switching in as player 2. So as Joshua had completed the level 1 of the game, let's kind of upgrade to 64-bit because we are considering a new thought process in the whole disruption bit, which is coming forward as the level 2. So disruption, as you all might know, is a set of strategic measures in order to interrupt and neutralize threats in a way that the impact on the users and business is kept minimal. So let's see how are we leveling the fields with the threat actor and using disruption to win the game here. So just starting with disruption, how is disruption different for an NHI when compared to any other entity or asset disruption? So just trying to understand how an OAuth application is identified itself makes it very complex, because an OAuth application can have an OAuth application ID, which is a global representation of the OAuth application, while it has a service principal ID, which is a local representation of the application. And if we consider the ownership bit of it, the owner of the OAuth application will be the user who has created and registered the application, while the owner of the service principal will be another user who has consented to use the service principal in a particular tenant. And let's consider it as a multi-tenanted app. This is where this particular app can have multiple service principals across different tenants where different users have consented to it. So in this scenario, if this particular OAuth application is put into malicious use, what do we disrupt? And how do we disrupt? This is exactly how I was when I started to work on NHI. So this is exactly where we need a new thought process in order to disrupt such threats. And this is where let's kind of compare it and draw a parallel with a game of chess and try to understand it better. Any move that endangers the king is a wrong move, no matter how tricky it is. It's the same with disruption. Any action that jeopardizes the business is not an attack disruption, it's more of a business disruption, and business is king. Hence, we need a new thought process with a phased approach in order to handle the disruption. And we bring in game theory, a comprehensive framework where we incorporate a phased approach to disruption in a way that we have set of actions which we can impose across the kill chain, as well as we have set of game strategies which can also be used to disrupt the NHIs in a way that the impact on the users and business is kept minimal. Business, as usual, getting impacted is like running out of lives in a game, which would eliminate us from the game eventually. So we need a phased approach towards disruption, and let's move to phased disruption. So here, to start with, our motive is to disrupt an NHI here. But still, there might be a human identity associated to it. What do we do about that? Unless and until we identify the human identity and disrupt it, it's not a complete attack disruption. Hence, we need to identify the HI or associated to NHI and kind of disrupt it. So here, before looking into the whole kill chain, let's kind of phased and let's kind of divide it into multiple phases, because just considering the evidences here, we'll have a combination of both OAuth application based activities as well as the user activities here. So if we try to phase it towards the farther right, where we have the OAuth application active, we'll see the OAuth application accessing multiple APIs to perform malicious activities. As we move towards the left, we have a combination of both OAuth and the user activities, where the compromised user kind of performs certain actions which are on the application, that is creating or registering an OAuth application or adding a service principal or adding secret, etc. This is where, with the phase disruption, we need a set of weapons. So let's choose the weapons and delve into the actions. So now here, we have considered only a subset of weapons because it's an infinite game of disruption that we have here. But sticking on to the scenarios that we have considered, we'll choose a set of weapons and try to use it. So to start with, removing secret from an application, deleting service principal, which might be part of a compromised application, deleting the application itself, removing service principal credentials that are being added, disabling signings from the service principal to any other application, revoking API permissions, be it Graph API or EWS API, which is Exchange Web Services, or Azure Resource Manager APIs, to pick a few. Revoking access token to thwart an active session for an application or a compromised user. Disabling the sign-ins to the service principal, that is, users signing into the service principal. Revoking app role assignments, be it delegated or application level permissions, and revoking unnecessary high permissions. Now let's see, how do we use these weapons and tackle APTA? Starting from the farther right, we have the threat actor almost progressed to the final stage of the attack, where the attacker has access to the APIs. So at this phase is where we use the minimax theory in a way to minimize the maximum loss that has happened. So though the attacker has access to the APIs, we can revoke the API permissions to minimize the maximum data loss via collection or exfiltration. As we move to the lateral moment and further left of the attack chain, If we are confident enough with the evidences, we can make such similar strategic moves throughout the kill chain. And at the latter moment stage, we can use the Stackelberg strategy where we lead and the other player reacts. This is where we, as the defenders, disable the sign-ins to the service principal, which is used to do a lateral movement, thus thwarting the attacker from having any other possible actions, and the attacker is forced to look in for other options to laterally move. Now at the discovery phase, we leverage the Bayesian inference here. This is where we kind of consider anomaly scores, behavior signals, as well as kind of have risky probabilities and try to kind of revoke the app roles that is actually giving the permission or the privilege to perform discovery activities. And moving on to the credential access phase, this is where the threat actor is seen accessing secrets, and it has high permissions in a way that which is leveraged to access stored credentials like key vaults, etc. This is where we also leverage the zero-sum scenario, wherein one's gain is another's loss. So we gain complete control by revoking the high permissions as well as revoking the access token, which would thwart the threat actor from doing a token theft. As we move to the defense evasion, we have seen the threat actor evading detection by using a service principal rather than using the compromised user. And the threat actor never stops. So the threat actor tries multiple attempts to perform defense evasion techniques. And this is where we use the repeated game strategy, wherein we use pattern-based disruptions. And we disable the service principal sign-ins here at this point. As we move to privilege escalation, the attacker is seen escalating privilege or trying to escalate privilege by accessing credentials or adding credentials to the application as well as adding secrets to it. So this is exactly where we use the Nash equilibrium, where we have a steady state. We try to maintain a steady state. That is, for every attempt to perform privilege escalation, we kind of refresh the secrets and credentials in a way that we maintain a steady state with the threat actor, and the threat actor is forced to make multiple attempts. Still, we are secured. And as we move to the persistence phase, this is where actually everything starts with the NHI, because post the attacker compromises the user, this stage is where the attacker creates an OAuth application or creates a service principal. So we leverage the dynamic game strategy here, wherein we adjust to the behavior of the threat actor in order to stay ahead. So we try to understand the behavior of the threat actor prior to creating an NHI, and then stay ahead by disabling or deleting the service principal here, not letting the compromised app to get active or to do any malicious activity. And as we move towards the farther left, we could have stopped the entire attack from happening if we had revoked the token for the compromised user. It's not as easy as said, but we can actually do this if we consider a commitment strategy. And this is where we have a set of committed actions which are irreversible. Irreversible in a way, the threat actor is forced and is restricted and has the constraint to move forward in this particular attack. Now, as we have completed the game with the APT1 or APT-A, let's move to the APT-B. So the weapons that we use all the way from collection to privilege escalation is almost similar, but we can use multiple strategies and try switching in. But the thing, it gets interesting at the persistence phase, where we have a dormant application which is being used by the threat actor. We have a compromised application as well as a malicious application. How do we disrupt here? And we use the same dynamic game approach by kind of understanding the behavior of the user prior to creating or accessing these applications. That is, by revoking the access token from the dormant application and thus stopping the dormant application to get active, removing the service principal in a way that it doesn't use the compromised application for any malicious use, and deleting the malicious applications that were created in order to perform any other malicious activity. And at the initial access, we could have revoked the session token. Now, let's level up with the learnings that we have. So considering the learnings, we should always have a strategic disruption action built into every phase with the detection. So disruption and detection should be hand in hand in a way that we kind of disrupt and not just have hard actions, but can have also soft actions in a way that we reduce the impact of the user threat actor on our system. Disruptions must be shifted to the earliest phases of the attack based on the identify NHI path. This is where we can actually thwart the threat actor at the stage when the OAuth application was created or the service principal was added. Having a clustering of NHIs across multiple tenants can help us generate intel, which would help us disrupt at an early stage for an N+1 customer or tenant. Because we have seen live campaigns wherein threat actors use a pattern in the application metadata or the behavior wise or even the indicators associated to these applications are similar. And actioning on inactivity based decaying on unused NHIs would help us disable or take actions on dormant or orphaned applications which the threat actors are putting into action. Now it's game on. Cybersecurity has always been a multiplayer game, and we as part of the defenders team must take proactive measures in order to tackle such threats. Not just OAuth applications, but we must expand this to multiple other NHIs as well as to multi-SaaS or multi-cloud environments in order to have a holistic view over this and to take the respective disruption actions. So the next time you see a suspicious activity, make sure to check if there is an NHI under the radar which is being abused, and make sure to use the right set of weapons to win the game against the threat actor. Thank you, everyone.